Hello, I am Dr. Ajay Sharma, Department of Electronics and Communication Engineering, Jimis Engineering Management Technical Campus. The subject that I teach in this semester for Electronics and Communication Engineering branch is Optoelectronics and Optical Communication. This is the main subject of 7 semester students. The topic that we will discuss today is types of optical fiber. Well, you know, actually, the optical fiber types basically grouped into three categories. First category based on a material that are used in manufacture of optical fiber. Second is based on the transmission mode, whether the fiber is a single mode fiber or a multi-mode fiber, means whether the fiber is support one mode or more than one mode, that is multi-mode fiber. And third category is on the basis of index profile, whether the profile is step index fiber, means the refractive index of the optical fiber change in one step if we goes from center of the core to the cladding side, or it increases gradually or decreases gradually from center of the core if we move towards a cladding side. So we have three types of groups. On the basis of that, we can say that the optical fiber has three types. One is based on material, second is based on transmission mode, and third is based on index profile. So first we discussed the optical fiber that is based on material. And we already know that as far as the material is concerned, optical fiber is made up of a plastic and a glass, means glass material and plastic materials are used in the manufacturing of optical fiber, right? So the core and cladding, which are the main parts of optical fiber, is made from plastic material and glass material. So in this category we have a first optical fiber which we called as a plastic core and plastic cladding, means the core and the cladding is of the optical fiber is made from plastic material, and this type of fiber cables have same material, so it is easy in production, means because the core region and the cladding region made from the same material that we called as a plastic, it is very easy to manufacture because the same materials are used. Just only the difference is that the core have a different refractive index as compared to cladding plastic material. Less expensive and easy to install, and mostly used in short distance and have a capability of 6 Mbps. So this particular fiber supports 6 Mbps speed as far as the signal speed is concerned. The second type is glass core with plastic cladding optical fiber, means the core region, which is the middle region of optical fiber, is made from glass, and the cladding region is made from plastic material. So this is a second kind of optical fiber cable. It is having a low signal loss, less affected by radiation, suitable for military application. So these are some uh, characteristic of this particular type of optical fiber, which come in the category of glass core with plastic cladding. And this is the picture that's shown. A middle region is of course a core region, and this black region is of course is a cladding region. So this is the second kind of optical fiber, which we called as a glass core with plastic cladding. Third category is glass core with glass cladding, SCS. So if you compare with the previous types in this category, it is having a lower signal loss than previous uh, fiber that come in this category. and more susceptible in radiation areas and losses signals, right? So core region have, if you see the picture, it is clearly shown that the core has higher refractive index as compared to a cladding uh, material. So second group of this optical fiber based on mode of transmission, or in that we talking about single mode fiber. As the name suggests, single mode fiber, this particular fiber supports only a one mode. So it is having only one path for light to pass. It is only one way, one style, one method uh, is to be possible for the propagation of light. That's why we call it a single mode fiber. And because this particular fiber support only a single mode, one mode, the reason is because it has a very small diameter of the core, 7 to 10 micrometer. It is very small. This is the reason why this particular fiber supports only one mode. But this particular fiber supports 40 gigahertz of bandwidth, and this particular fiber mostly used for long distance, like TV cables. So this is a picture of single mode fiber. This arrow suggests only one way of propagation is possible in this single mode fiber. That's why this fiber is called as a single mode fiber. Then second is multi-mode fiber. As the name suggests, it supports more than one mode. That's why we call it as a multi-mode fiber. So light takes more than one path to travel. There are various paths of propagation possible inside this fiber. That is why we call it as a multi-mode fiber. It supports many paths. Of course, and the reason is that as compared to single mode where the core diameter is very small, but in this particular case the core diameter is large. This is the reason why this fiber supports many modes. The diameter in this case is 20 to 100 micrometer, right, and is usually used for medium distance or high bandwidth requirements. And this picture, if you see the picture, it's in this particular three modes that we have to seen in this picture. One mode is seen as a green color. Second mode is red color. The third one is a blue color. So this is a multi mode because it supports more than one mode. And the third category in which the optical fiber is to be classified is based on the index profile. Or in this category, the first one is step index fiber. Step index fiber, the step word is associated with the refractive index, because here in this case the refractive index change only in one step, and we already know that the refractive index of the core is different from the refractive index of the cladding, and this is also be true that refractive index of the core is more as compared to cladding, and this is the condition for the propagation of light inside the core region. But in this case, step index fiber have a uniform refractive index of the core, means the refractive index in the core region is uniform throughout. Everywhere, this is the uniformity of the refractive index is to maintain inside the core region. So whenever you move from a core boundary to cladding boundary, only that case the refractive index change and it reduces, because the refractive index of the cladding is less as compared to the refractive index of the core. Right? So core have bigger refractive index as compared to the cladding. And these are the picture that shows, this is the picture that shows the you know the the parts of this optical fiber. We have a core region, which is the central region, then cladding region, then the jacket. Jacket protects cladding and core both. So jacket is the outer surface of the optical fiber cable. The second category in this type of optical fiber is the graded index fiber. If you compare with is this graded index fiber with the step index fiber, what you find the difference? The only difference is that the core of gradient index fiber is non-uniform. It is maximum at the center, and if you move from the center of the core, it is decreases, right? So in this gradient index fiber, the core has non-uniform refractive index, means the refractive index change if you move from central region to the cladding side region, right? And it is maximum at the center, or you may say at the axis of the optical fiber, right? And axis is the middle uh, middle assumed line of the optical fiber, and this is the core region. So refractive index is highest at the center, and it decreases till the end of the core. And if you look the pictures, it is suggests that again the the parts are same. The core part, which is the central part, then a middle part, which is the cladding part. There is a jacket. Jacket is used to protect core and cladding. So these is the pictures that shown that the parts of this gradient index fiber. N1, N2, N1 is the refractive index of the core, N2 is the refractive index of the cladding, N0 is the refractive index of air, A is the radius of core, B, small b is the radius of cladding. So this is shown in the figure. This is again a figure that shows different types of optical fiber on the basis of mode that fiber supports. First, it's single mode step index fiber. That fiber supports only a one mode. And again, look at this the figure where you can see that the diameter of the core is very small, N1, and N2 is the cladding refractive index, and N0 is air refractive index. Second is multi-mode step index fiber. This particular fiber supports many modes but come in the category of step index because the refractive index of the core is uniform throughout. That's why, but it supports many modes. That's why it come in the category of multi-mode step index fiber. Again, you can see from the picture that because this particular fiber is a multi-mode, that's why the diameter of the core is large as compared to the single mode fiber. Third category is multi-mode graded index fiber. Multi-mode matlab this particular fiber also supports many modes but come in the category of graded index. Why? Because the refractive index of the core is not uniform. It is maximum at the center and it is decreases when we move from central axis of the fiber towards the cladic region. That's why this particular fiber come in the category of multi-mode graded index fiber. And one condition that we all should know that refractive index of the core is always greater than the refractive index of the cladding. This is the necessary condition. Then come from the numerical aperture. Numerical aperture is the property of the optical fiber, and it signifies the capability of the optical fiber to gather a light. Light gathering capacity can be measured from this numerical aperture, right? Or every fiber has its acceptance angle. Acceptance angle is that angle where the ray if come in the category of acceptance cone, then definitely total internal reflections takes place and nothing to be reach out at the cladding side. So for total internal reflections, all the ray must be fall in acceptance cone, right? So this is the condition, and this is also one of the V number that we're talking about later. This V number is equals to 2 pi upon lambda into Na. Na is the important factor in light launching designs into the optical fiber. So numerical, if you want to calculate the numerical aperture, it is the n1 square minus n2 square under root. N1, N2 are the refractive index of the core and cladding simultaneously. Acceptance, so maximum acceptance angle, which is denoted by alpha max, is that which gives total internal reflection at the core cladding interface, right? So when alpha barabar alpha max then theta barabar theta c, rays with alpha greater than alpha max become refracted and penetrate the cladding and are eventually lost. So total acceptance angle is twice of L max, and this becomes the cone. So three technical terms come in the picture. One is numerical aperture. It is the light gathering property of optical fiber. It gives you the idea how much the light that the particular fiber gather or support, and it is calculated by knowing two parameters. One is N1, another is N2. N1 is refractive index of the core, N2 is the refractive index of the cladding, and if you take the under root of that, that become Na. Also, you can also calculate this acceptance angle, which is the sine of acceptance angle is equals to N1 square minus N2 square under root upon N0, where N0 is the refractive index of the air, right? So we're talking about several parameters that are used in optical fiber. One is average refractive index, which is calculated by N1 plus N1 upon 2. If you take the average of refractive index of the core and cladding, it becomes average refractive index. Del is normalized index difference and it is defined as N1 minus N2 upon N1. V number V number V number is a it's a unitless quantity, and it is defined as 2 pi a upon lambda n1 square minus n2 under root. So this V number is a numerical value that gives you the idea whether the fiber is single mode or a multi mode. If you if you have a fiber having different, if you have a fiber having certain A, if you know what is the wavelength of the light, if you know the refractive index core and cladding, then you can calculate this V number. Then some numerical value come in the picture. If this value is less than 2.404, if you put all these parameters of the optical fiber to calculate V, and if this comes less than 2.405, then we can say that this fiber support only one mode. And obviously this V is directly proportional to A, where A is the diameter. So if the diameter of the core region is less, then obviously V is less. When V is less, it may be the possibility that it come in the category of single mode, right? When V is greater, okay. Then if V is greater than 2.405, it come in the category of multi-mode, means fiber supports more than one mode. So by knowing that this particular fiber single mode or multi-mode, by calculating this V number, we can also find out the number of modes that a particular fiber supports. It actually depends upon the V number. If you square the V number and divide by 2, then the value M come in the picture, and that M is equals to number of modes supported by optical fiber. Very much.